The atmosphere is the blanket of air that surrounds the Earth. It is made up of different gases, 78% nitrogen, 21% oxygen, and the remaining 1% is a combination of water vapour, carbon dioxide, argon and traces of other gases. It consists of 4 layers: the troposphere, stratosphere, mesosphere and thermosphere. The troposphere is the bottom layer of the atmosphere. It is around 12 kilometres high and the majority of the weather occurs here, so planes tend to fly just above this layer. Past the tropopause in the stratosphere to avoid turbulence. This is around 10 kilometres high, but this varies due to latitude and seasons. The stratosphere is very dry here, and the air contains little water vapour, so little weather exists, and the air remains stable, meaning small vertical disturbances dampen out and disappear.
Weather is the state of the atmosphere at any given time with respect to temperature, moisture, wind velocity, visibility, and barometric pressure. Decisions based on weather can drastically affect the safety of a flight, particularly during takeoff and landing when the plane is in the troposphere.
The International Standard Atmosphere is the recognised model used to show the variations in the atmosphere against geometric altitude in terms of temperature, pressure and density, allowing us to calculate performance for any altitude on any aircraft. It shows a decreasing temperature as you move up the troposphere, a constant temperature around the tropopause, then increasing temperature in the stratosphere. We can also see that pressure decreases exponentially as altitude increases. This model is based on average conditions in mid-latitudes and shows a hypothetical average day, which the actual atmospheric conditions can then be compared to.
Pressure is the force applied perpendicular to the surface of an object per unit area over which the force is distributed. For example, if there is a sealed column of air that had a footprint of 1 square inch and is 350 miles high, it would take 14.7 pounds of effort to lift it. If the same column was lifted at 18,000 feet above sea level, it would take 7.4 pounds of effort to lift it.
We can see the effects of temperature and pressure on flight when we look at density altitude.
Density altitude is air density given as a height above mean sea level. On a hot humid day, the aircraft accelerates more slowly down the runway, and therefore will move faster to attain the same lift and will climb more slowly. The less dense the air, the less lift, and the longer the distance will be for takeoff and landing.
So if it gets too hot in the plane, we can just open the windows and let the cold air in?
No. When a plane is up in the air, the atmospheric pressure inside the plane is normal, but outside the plane is a lot smaller. You may ask how the pressure in the plane is maintained. There is an outflow valve located at the tail end of the plane. As soon as the plane takes off, the once opened outflow valve closes and the cabin starts to pressurize.
Let's say you did open a window. Areas of high pressure tend to diffuse into areas of low pressure, so all the air inside the plane would quickly move out of the plane and go outside, and basically everything in the plane would be sucked out. You would mainly die from lack of oxygen. Normally the atmosphere is 21% oxygen, which is perfect for us. In high altitudes where the air is thinner, the small quantity of air means a smaller quantity of oxygen. We would die of hypoxia.
We are currently 1,500 metres above sea level.
And as you can see, the temperature has really decreased.
We can really feel it decrease in the atmospheric pressure.
We are now at sea level.
And as you can see, it's much warmer.
We can feel an increase in the atmospheric pressure.